Hello. So, welcome to chemistry. Now, the first concept or the first unit would would be units of measurements. Now, I decided to start with units of measurements because as a teacher and as one basically who has tutored and helped hundreds of students uh, with chemistry, one of the things that I've come across is the fact that students get stuck with simple dimension analysis. So I took the time out to basically create um, a series of questions that tackle this problem. So I'm going to talk about several units in chemistry from a problem perspective rather than conceptual me talking too much. I believe you learn better when you solve more problems. And that goes for any topics, whether it's chemistry, math, physics, or any form of concepts. All right, so let's see. I'm going to talk about length, area, volume, mass, density, and temperature. This video would focus mostly on length and area, and then the next video will focus on volume and mass, and then the third video will focus on density and temperature. So let's see our first problem. It says the eye can perceive objects which have a diameter of 0.2 mm. Mm stands for millimeters. What is the diameter in inches? Round answer to three significant figures. Okay, so there are three things here. It says diameter of the eye is 0.2 millimeters. Now, what is that? What is the diameter in inches? So we have to basically convert millimeters to inches, and we have to round our answers to three significant figures, meaning basically three numbers. So here's a hint. We're going to use the fact that 1 inch equals exactly 2.54 centimeters. That's an exact measurement, by the way. 1 inch equals 2.54 centimeters. The goal is to convert from millimeters to meters, from meters to centimeters, and then from centimeters to inches, because our final answer has to be in inches. As you can see over here, it has to be in inches. Let's see if I can write on this pen right here. Final answer has to be in inches. There we go. Okay, so what do we have here? We have, all right, let's see how I solve this. So the first thing I want you to see is this. Most of the solutions in this video will look something like this, where I solve it on a piece of paper and I attach the solution to my PowerPoint. So here are some things we need to know. We need to know this. We need to know that 1 inch equals 2.54 centimeters. We need to know that 1 meter equals 100 centimeters, and we need to know that 1 meter also equals 1,000 millimeter. These are what we call conversion units. In most chemistry tests, even on Regents, they give you these units, so you don't really have to memorize them. But it's something good to memorize, so you don't have to keep looking for them. So what are we giving? We are giving 0.2 millimeters. That's what we're giving. We're giving 0.2 millimeters. So what you want to do is you want to set up a proportion. Now, what I usually teach students is that you put the unit in the bottom that is the same as the unit that is given to you. So they give you millimeters. So you put the millimeters in the bottom, and then you put the unit that you're looking for on top. So here I'm going from 0.2 millimeters to meters. Again, listen to that. I am going from 0.2 millimeters. I'm basically converting from millimeters to meters with this proportion. And then from meters, I'm going to centimeters. You see the meter and meter. And then from centimeters, I'm going to inches, as you can see here. So the best thing to do is how does this work? So once you set up the proportion in this system or something similar to this, where you can see how the units cancel out, this is called dimension analysis. When you cross out the units from top to bottom. From top to bottom. Sorry about that. From top to bottom. Now we are left with only inches, which is what the question requires. You see, from meters, from let's go back, from millimeters to inches, basically. Okay, so once you do that, the next thing you want to do now is how do you plug this inside a calculator? Well, it's fairly simple. You take the 0.2, you multiply it by 1, and then you divide it by 1,000. Whatever you get, multiply it by 100, then divide it by 1. Whatever you get, multiply it by 1, then divide it by 2.54. Again, because the units cancel out. Here we have units that cancel out. You're left with inches, and which gives you 0.00787 inches. Here you can rewrite this in terms of exponentials. So the decimal moves back 1, 2, 3. So we have 7.87 times 10 to the negative 3 because we move to the right 3 times. 1, 2, 3. So let's see. Next problem. Area. So now we have spoken about length. As you can see from the title, the goal was to talk about length, area, volume. Now we're moving on to area. So let's see this problem. It says 1 cubic millimeter of oil is spread on the surface of water. So usually when you spread, so that the oil film has an area of 1 square meter. What is the thickness of the oil film in angstroms units? Okay, so if you take a closer look, there are some things that they give us. They give us 1 cubic millimeter of oil. So this is the volume that's spread on the surface of water so that the oil film has an area of 1 square meter. So here I'm circling the important things from the question. What is the thickness of the oil in angstroms? So they're looking for thickness, and in which units they want it? They want it in angstroms. Okay. Now here I have this picture here to show you what basically what the question is asking for. So when you have oil droplets in water, it forms this thick layer. So they're asking for the distance from here to here. That's what they're asking for. When you drop oil on water, it forms a thick layer between the water and the oil. That's what they're looking for, the thickness indeed. Okay, let's move on. Let's see the hint. Okay, so here are some useful conversion factors that I think would help you solve this problem. 1 meter equals 10 to the 10 angstroms. Again, this most likely will be given to you on a reference sheet. If not, you can memorize it. 1 meter equals 10 to the 10th power angstrom. Angstrom has this symbol here. Area equals 1 millimeter square. Volume is 1 cubic millimeters. And volume equals area times thickness. Now, where am I getting this from? And where am I getting that? I'm getting it from the problem. The problem tells us, if you go back to the problem, it says 1 cubic millimeter right here. And that's the same thing here, 1 cubic millimeter. Cubic meaning 3, millimeter. And then 1 square meter. 1 square meter, that's the area. 1 square meter, 1 square meter. Now, volume equals area times thickness. So if you're looking for thickness, all you have to do is what? Think about it. How do you get thickness by itself? Well, you can divide the area on both sides, and then you have volume over area. So here's the hint. First find the volume, then the area, and then divide the area into the volume. Pause the video and take time to solve this problem. Okay, so here's my solution. So let's go over this together. So again, here's the known quantities that I had circled in the last video. So 1 meter equals 10 to the 10th angstrom. The area was given to us. Volume is given to us. And what's volume? Volume equals area times thickness, D. And then we solve for D. But we isolate D. So we divide A on both sides. So D equals V over A. So this is what we're looking for right here. This. Thickness equals volume over area. So we need to find volume first. And then once we find volume, we look for area. And then we divide the two. So let's look at the right side. We're giving that the volume is 1 cubic millimeter. We're giving this. This is what we're giving. I pointed this out. So what am I doing? I'm going from millimeters to meters. And because that is not usually given to you as a cube, I'm just cubing it. 1 meter equals 1 meter in general equals 1,000 millimeter. But because I want it in cubes, I'm cubing both the meter and I'm cubing also both the millimeter. And that's why I have the cube here. Now, 1 meter is given to us here, right here. That 1 meter equals 10 to the 10th angstrom. So, but because I want it in cube, I'm cubing both the top and the bottom. Anything you do to the top, you do to the bottom. Again, why am I setting it up like this? Because I want this to cancel out, this to cancel out with that, millimeters to cancel out, and I want meters to cancel out. Now I have angstroms that is left. So we can use our calculator to plug this in. 1, divide that by 1,000 cube, multiply that by 10 to the 10th cube, should give you 10 to the 21 cubic angstroms. Now, once you find the volume, we need to find the area. Again, its area is given to us as 1 square meters. So I'll take the square meters, I'll convert it to angstroms. It's given to us that 1 meter equals 10 to the 10th power angstrom. So to get it in squares, all I'm doing is I'm squaring both sides. Square, so I cancel this, and I multiply them together, I get 10 to the 20th power. Now I just divide the volume to the area, and I have 10 angstroms. Now before we move to the next concept, volume, I'll stop the video here just so you can take time just to go over it again, and then on the next video we'll talk about volume and mass. So again, just to recap, we spoke about length and area. In the next video we will talk about volume and mass, and then the final video we'll talk about density and temperature. Thank you.